Hey gang, so let's do our fall midterm review. Alright, so here we go. So solving equations and inequalities. So let's review. When we solve equations, we are going to solve and get x equals something. So I'm going to start here and I'm going to notice that I have to hippity-hoppity distribute a property. So I'm going to do 6 minus 2 times x will give me 2x. Negative 2 times negative 6 will give me positive 12. Over here I'm going to have 3x plus 4. Now remember, I kind of told you, if you have more than two things on any one side, you can probably put something together. I notice here that I have like terms. 6 and 12, I can put those together and get a positive 18. I'm going to mark them off. And then I have minus 2x equals 3x plus 4. I'm going to get my x's on one side and my numbers on the other. So I'm going to subtract 18, subtract 18. Didn't leave all much room to work, did I? I might need to get me some paper. I happen to have some already, yeah. Alright, so I'm going to go right here. So this is going to give me negative 2x equals 3x minus 14. I'm going to move this 3x to the other side. Negative 2 and negative 3 will give me negative 5x equals negative 14. I'm going to divide both sides by negative 5. That's kind of a yucky problem, isn't it? X equals 14 over 5. Alright, I'm just going to double check. Let's see, negative 2, negative 2x. We subtracted 3, subtracted 3. Yeah, I think that's right. 18 and 4 give me 14. Yeah, that's just a yucky answer. Here we go. Okay, this one, 6 minus 3 parentheses x plus 2 greater than 15. Now, because I write a lot bigger than I left myself room for. So here we go. So hippity-hoppity. So 6 minus 3x, negative 3 times 2 will be negative 6, greater than 15. Remember, we're just going to draw a line. If you have more than two things on a side, there's probably something you can put together. 6 and negative 6. Oh, what happens there? 6 minus 6 is 0. So that's gone. So negative 3x is greater than 15. I need to get rid of that negative 3 there, so I'm going to divide both sides by negative 3. With inequalities, the only rule you have to remember is if you divide or multiply by a negative, you have to flip the sign. So x, flip the sign, 15 divided by negative 3 is negative 5. If I were to graph that, I would put 0, negative 5, and 5. I would circle negative 5. There's not a line underneath it. Remember, when it has a line under it, you color it in. If it doesn't, you leave it open. This doesn't, but it points to the left, so I am going to shade to the left on that. Okay, I'm going to do number 3. I'm going to come down here. I'll put number 3 here. I'm going to do 25 less than or equal to 2x plus 3 less than 53. So this is a compound inequality. We didn't do a whole lot of these in class. I don't even know if we did one of them. So what we're going to do on this, because there's not one like that on your test, I'm just going to mark this side off. All it means is you have two inequalities. So we're going to work this. I'm going to do minus 3, minus 3. Why did I do that? Why didn't I move the 2? Well, since 2's over here and there's a number over here, if I move the 3 first, I only have to do that once, because that'll cancel out, and this will leave me 22 less than or equal to 2x. And now I can divide both sides by 2 to get that x alone. So that's going to be x. 22 divided by 2 is 11. I didn't need to flip the sign because I didn't divide by a negative number. So I don't like to read this backwards, so what I'm going to do is flip it around. I'm going to say x and 11. It's pointing to the 11, so when I swap sides, I want to make sure that my inequality is still pointing to the 11. I would do a number line with 0 and 11, 11 and negative 11. I would circle the 11. This has an inequality, has the equal sign, so I am going to color it in. It's pointing to the right, so I'm going to shade to the right. All right, I'm just going to pull my paper over here because I don't have enough room to write. Okay, so let's do negative 2 over 3 x minus 8 greater than or equal to 10. And then it's got the or, and then it's got the other one. So we're going to do both of these. So here we go. There's nothing to distribute, so I'm just going to start off. I'm going to make this my x side and this my number side. So I'm going to add 8 to both sides. So that's going to be negative 2 over 3x. Cancels out. Greater than or equal to 18. Now I've got this 2/3 here. You've got a couple of different options. One is when you have something times something, we just divide, right? Divide by negative 2/3, divide by negative 2/3. And you're thinking, wait, what? Yeah, you just divide by it. It's a fraction instead of a whole number. So I'm going to do alpha y equals, and I'm going to do negative 2 over 3, right? And then I'm going to say, what if I divide that by alpha y equals? Well, if I divide it, I shouldn't have done this side because those are going to cancel out, right? What I should have done is alpha y equals 18 on top, and on bottom, alpha y equals on the bottom, and I'm going to do negative 2 over 3. So 18, and this equals x. Now, I'm dividing by this negative, aren't I? If you divide or multiply by a negative, you have to flip the sign. So flip the sign, and we get negative 27. I could graph that if I wanted to, but I don't think I'm going to graph it. I'm just going to leave it like that. Okay, now the other one of that said, where was it? Oh, it said, and it was just another problem. It says 2x plus 4 parentheses x minus 8 is greater than x minus 2. It's just another problem. We're just going to work it. We're not really doing the compound inequalities the way they wanted us to. 2x plus 4 times x is 4x. 4 times negative 8 will be negative 32, greater than x minus 2. If you have more than 2 terms on a side, we can probably put something together. So I think I can put, oh, there it is, not that. 2x and 4x give me 6x minus 32 greater than x minus 2. Let's add 32 to both sides. So 6x is greater than x. 32 and 2, and that's subtracting, so that'll give me a positive 30. Remember there's a 1 right here, so I'm going to subtract 1x, subtract 1x. Now do I have to flip the sign on this? I'm subtracting. No, I'm not going to flip the sign because I'm not dividing, I'm only subtracting. So 6 minus 1 will give me 5x, greater than, those cancel out, 30. I'll divide both sides by 5, and I'm going to get x is greater than 6. All right, lots of inequalities. Let's solve. Solve for x. I think what they were trying to do here is a literal equation. Cx minus 10 equals negative 5. We'll just solve it. I'm not sure what they were doing on that one, but we'll just go with it. All right. If I was solving for x, I would start by adding 10 to both sides. so that'll cancel out. So I'll get CX equals 10 minus 5 is 5. To get the C away from the X, this is multiplication. To undo multiplication, I just do division. So X equals 5 over C. Let's see, solve for L. So on this one, they give me 2L plus 2W equals the perimeter, and we're solving for L. All right, so let's move everything away from L. So I'm going to move 2W to the other side. So that'll be 2L equals P minus 2W. I can't really do anything there, so I'm going to leave it like that. To get the 2 away from the L, I'll divide both sides by 2. So I'm going to be kind of lazy. L equals P minus 2W over 2. All right, so that gets that one. Now let's look at number 7. I wonder if I could go back up here and put this down here now. There we go. Okay, so last week David practiced the piano for 3 hours longer than Rick. Together, Rick and David practiced for 11 hours. How many hours did each practice? So maybe we could say that David, let's use D's. Sometimes when I use the letters of their name, I do a little better. And then Rick, we'll make him R. So together, they practiced for 11 hours, right? And last week, David practiced, he had practiced longer than Rick. So if I did this, if I said Rick is R and David practiced 3 hours longer, could I write that David is Rick's time plus 3 hours, right? Couldn't I say that? And if I add David's time, I'll put that in parentheses, and I add it to Rick's time, how much should this add up to? It should add up to 11 hours. So the question is, how many hours did they each practice? Well, R plus 3 plus R equals 11. So that's 2 R's, right? R plus R would be 2R plus 3 equals 11. I'm going to subtract 3 from both sides. So 2R is going to equal 8. I'll divide by 2, and I get that R is 4. So what does that tell me? That tells me that Rick, he practiced for 4 hours. And David is 4 plus 3, so David practiced 7. All right. Tina is saving to buy a notebook computer. She has 2 options. The first option is to put away $200 initially and then save $10 every month. The second option is to put away $100 initially and save $30 every month. After how many months would Tina save the same amount with either option? So I'm going to go over here because I just don't have enough room on this paper. Sorry, guys. All right, so here we go. So her first option is she could save $10 every month, right? I'm sorry, let's do it this way. She could put away $200, right? The first option. And then she's going to save $10 every month. Option 2 is to save $100 initially. And she's going to put away $30 every month. When will these two be equal? So you set the 200 plus 10, or plus 10 times x, equal to the 100 plus 30 times x. And you're just going to solve this, okay? I'm not going to work that one. I'm going to let you work it. This is your x side. This is your number side. So I would move the x over here. Move the x over here. And then after I did that, I would subtract 200 from both sides and solve it. So pause your video so you can do that. And work that next one. All right, what is the difference between no solution and all real numbers? All right, no solution. That means no number will work at all. There's no number that satisfies the equation. All real numbers means any number will work. No solution would be something like 4 equals 8. That is not a true statement. Another one that where you'd get all real numbers is like 4 equals 4. You get a true statement. So this is true, and this one you get a false statement when you solve it at the end. All right, domain and range. First off, if I give you a table, you would say, oh, Mrs. Dean, this is discrete. This is continuous. This one is discrete because I'm counting the points. All right, so let's do the domain. This is what kills us all the time. Oh my goodness. All right, domain is the x. So it's -2, 0, and 2. The range on this one is 4, 8, and 12. I don't expect for anybody to miss those. But then you get to this one and it's like, oh, what happened? Okay, so the domain. This is a continuous equation. I am drawing it, so I need to put my inequalities because it is continuous. Don't forget. All right, so domain is the x. What's the furthest out I go on the x-axis? I go to right here. And the furthest out this way is right here. So my endpoint is -5, -2. This one is over 4, up 1. I look at these endpoints and I focus on the x value. I don't need the y's, I only need the x. So I go all the way out to -5 and out to 4. Those are my two endpoints furthest out there. Okay, now I need to look at how tall does it get. So I look here and I find the absolute lowest point. Well, here's the lowest point. It's there too, but it's right here too. So this is 0, -2. And then I look what's the highest I reach, and I reach up here, and that is -2, +3. So I don't need the x, I only need the y for the range. So my lowest is -2, and my highest is 3. And there is my domain and range. Watch that again if you need to. Okay, this one's discrete, so the domain is -5, 7, and 12. It's easy when they're listed like that. And the range is just going to be 12, 22, and 32. Now you might be thinking, but look, this one goes to 2. Do I need to list 12 twice? No, you just list it once. Mappings are the easy ones. You just list your numbers. All right, so here we go. Now we've got another one that is continuous. So as soon as you see it's continuous, you know that you're going to have these inequalities. Now, a while ago, I put the equal sign under it, not even thinking I should probably not do that, but we'll look. So I'm going to go on the x-axis. What's the furthest out point I go? Right here. And that point is 1, 2, 3, 4. So -4, -2. And then this point here is the furthest on the right. So 1, 2, 3, 4, 5, 6, 7. So over 7 down -2. So I don't need the y's, I only need the x's. I go all the way out to -4 and all the way out to 7. I have a solid circle on each spot, so I do actually equal it. Now let's look at how low it goes. How low does it go? Here's my lowest point. That is an open circle. That is 1, 2, 3, 4, 5, 6, 7. So 0, oh no, it's not 0. What is it? 1, 2. It's 2. So we go over 2 down -7. And then I want to look at the highest point. You know what? This line right here is the highest I go. So I'm just going to go right here. That ordered pair right here would be 0, -2. All right, so remember we don't need the x values, we need the y's. So I go down to -7 and up to -2. The low to the high, the lowest point to the highest point. This has an open circle, so I don't equal -7, but this is a solid line, so I do equal -2. There it is. Watch it again if you need to. All right, on this one, this is discrete again, so I'm just going to list my points. On my x, I go out, let's see, this is 2, 4, 6. So I go out -6. Oh, wait a minute. Okay, that's confusing. Oh, no, it is marks, isn't it? 1, 2, 3, 4. 1, 2, 3. So that's actually going to be -3. That was kind of hard to read. -3, +1, and they're both on 1, so I only have to list the points once. On the y, I go down 1, 2, so I've got one at -2, one at +2, 3, 4, and one at 4. Okay. Last one, it looks like it's starting right here, and it's got an arrow showing that it goes for forever. So the domain and the range. It's continuous, so you know what? I'm going to have to put my inequalities because it's continuous. I'm going to go out here and find the furthest x point that it reaches. You know what? It's going to keep going like that, isn't it? It's going to go forever. It's never going to stop. So that means it's going out to -infinity this way. What's the furthest point on the right? Oh, it's right there. 0, 0. Okay, I don't need the y values. I only need the x. So I go from -infinity all the way to 0. You can't ever equal -infinity, but it's a solid circle there, so I do equal that. Now, another way to say this right here is that, or x is always less than or equal to 0. Remember, when you have the infinity on one side and a number on the other, it's okay to mark this side off and just read that. That's probably more what you're going to see on the test. On the y, what's the highest value it reaches? Oh, it's going to keep going, isn't it? So my highest value is infinity. There's no end point that I can do like on the other ones. The lowest y value is right here. It never goes below that on the y-axis. So that point is 0, 0. So I don't need the x. The highest is +infinity, and the lowest is 0. You can't equal infinity, but you can equal 0. So 0 is less than or equal to y less than +infinity. If I wanted to mark this off, I could just say that 0 is less than or equal to y, or switch it around, and y is always bigger than or equal to 0. Either way, lots of different ways we could do that. I know domain and range stumped everybody, and my apologies. I wish there was some great way to make you be able to memorize that faster. All right, give an example of something discrete. I love M&Ms, so I'm going to say M&Ms in a bag. Dogs in a kennel, calculators in a case, keys on a keyboard, points on a graph, things you can count. Continuous would be rain, water in a glass, snow on the ground, how long your hair is, things you would measure. So maybe you want to write that, measure and count. Okay, a ball is dropped from 250-foot building where y is the height and x is the seconds. What is a reasonable range of this situation? That's actually a really good question. All right, I'm going to change pens real quick. So if we're on a building, I'll draw my building here, and we drop a ball. So my ball comes out, and it hits the ground. The domain, the height is y, x is seconds. If I'm talking about the domain, I am talking about the time, the seconds. About how long do you think it would take a ball to drop 250 feet? What, maybe 5 seconds? Is that a long, what do they call that, hang time? Is that too long? 1 Mississippi, 2 Mississippi, 3 Mississippi. We're going to say that it takes it 5 seconds to hit the ground. A domain would be time is 0 when I drop the ball, less than or equal to x less than or equal to 5 seconds. About 5 seconds to hit the ground. That would be my domain. The range. Well, the range is up here at 250 feet. And when I drop the ball, what's the lowest it's going to hit? Yeah, it's going to hit the ground at 0 feet. So I would say it goes from 0 less than or equal to y less than or equal to 250 feet. There's my reasonable domain and range. So domain is how long was it in the air? Seconds. H or y is the height. What's a reasonable height of this? How tall is it? 250 feet all the way down to 0. So that's how tall it is. If you thought about it from just a graphing standpoint, you'd go 1, 2, 3, 4, 5, and this will just say right here is 250. So it would look something like this. My graph. All right. You and some friends are ordering medium pizzas that cost $5 a piece. Let y represent the cost. X is going to represent the number of pizzas. What's a reasonable domain and range of this? All right. You could buy 1 pizza. You could buy 2 pizzas. You could buy 3. You could buy 4. Can you buy half a pizza? Yeah, no. You might get in a little bit of trouble for that. On the y-axis, we have the cost. So we're paying $5. So we'll have $5 for 1, 10, 15, so on. If you buy no pizzas, how much did you spend? You didn't spend any money. Pizza sounds pretty good for dinner right now. If I buy 1 pizza, it would be $5. If I buy 2 pizzas, it would be 10. 3 pizzas, 15, and so on, right? It's going to keep going up. So the domain, I could buy no pizzas. 1, 2, 3, on and on and on. What's my range going to be? Well, I could spend no money, or $5, $10, $15, and so on. There's my reasonable domain and range. All right. Steve drives a taxi. He charges $2 flat fee plus $1.50 per mile. The table below represents this function. A function that can be used to predict the total cost of any trip on Steve's travel. Interpret the slope and the y-intercept of this situation. Well, let's look at this. So he's charging $2 plus $1.50 per mile, right? And if I want to call it a function, I would just say f of x equals. Well, here's the y-intercept. What does that mean? If I were, it didn't leave me any space to really graph it, but if I were to graph this, 0, 2 would be here, 5, 9 point, whatever, and then it's going to go up and up. It'll look something like this. So what does this right here represent? That is his flat fee that he charges. So just to get in Steve's car, he charges you $2. So you're going to say that that represents the flat fee. Now, what is the slope? Well, the slope is right here. Now, let's say you didn't recognize that. You're like, oh, I don't know. Well, do the change in y over the change in x. So 0 to 5 is going up by 5. Let's do this. Let's do 9.5 minus 2. So this is 750. So the change in y over the change in x is 750 divided by 5. So I'm going to take my answer, 750, 7.5, and divide it by 5. It's $1.50. Well, if you remember, that's what they told us he was charging per mile. So my slope would be $1.50. Reasonable domain and range. All right. Now let's think about this. You're doing distance. Are you counting the distance? Are you counting, I went 1 mile, 2 mile, 3 mile? Or if you drive 1.3 miles, is he going to charge you for that 0.3 of a mile you went? Yeah, he sure is. So this is continuous. So I'm going to say you could go no miles. This is the domain. Domain is the miles. Y is the cost. You could go no miles, or you could go up to, does it tell me how far I can go? He doesn't tell me how far I can go, so he could go, I don't know, reasonable domain and range, I'd probably say he probably is not going to go more than 100 miles. If you told me on this one infinity, I'd probably question you on it, but I might give you credit for it. On the range, the money, what does it start at? Hopefully you said $2. Yeah, less than or equal to Y, less than or equal to, well, let's figure out. If you went 100 miles, you would do $2 plus $1.50 times 100 miles. That's 152. So 152 would be my reasonable range, because I don't think a cab's going to go more than 100 miles. All right, so moving on. I know it's getting long, 30 minutes. If you need to take a stretch break, pause your video, take a stretch break, get a drink, go to the bathroom, and then come back. All right, use the given functions to find the values. So here we go. We've got three functions, f of x, g of x, and h of x. F of negative 3. I'm going to do this right here. I'm going to go to y equals. I'm going to use my calculator. I'm going to do 4x squared minus 3x plus 27. So here's my f of x. If I want to know f of negative 3, that means when x is negative 3, what's the y value? What do I get out of that? So second table, I just need to go to negative 3. What do I see? 72. So f of negative 3 is 72. Do I have any more f's? Oh, no, I don't. All right, g of 20. So I'm going to go to y equals. I'm going to clear that out. And I'm going to go to g, which is alpha y equals, it's 1/2 x minus 6. And I need to know when x is 20, what do you get? Alpha y equals you get 4. So that is 4. All right, now we need h of negative 2. So y equals 2x. To do the third, you do the house top and then 3. House top is this one right here. And then you can put any of them up there you want. Move to the side, and then we're going to do plus 1. All right, and we need to do negative 2. So when x is negative 2, what is the y? So second table, negative 2 is negative 15. So this is negative 15. All right, f of g of negative 4. So we need to work from the inside out. So let's find g of 4. Let's get that value. And I don't think we have that one yet. Nope. So y equals, let's go to g and let's put in alpha y equals 1/2 x minus 6. Now some of you like to put them all three in at the same time and do it. I do not, because I make mistakes when I do that. So g of 4 is negative 4. Okay, so there's g of 4. Now what it wants to do is we're going to take negative 4. So think of it like this. So now we're finding f of, well, g of 4 was negative 4. So now we're finding f of negative 4. This is like a secret number. We just figured it out, and now we're plugging it in. So what is f of negative 4? So let's go to y equals, and let's put in f again. 4x squared minus 3x plus 27. Second table, I'm doing negative 4. And there it is, it's 103. So f of negative 4 is 103. So f of g of 4 is 103. All right, I'm going to let you do this one. I'm going to walk you through it. G of f of h of negative 1. So you're going to do this. You're going to find h of negative 1, and you're going to get an answer. When you get that answer, you're going to find f of that answer. And that's going to give you another answer. And when you get that answer, you're going to do g of that answer. And that'll give you your final answer. All right, h of negative 1. Plug in h, go to negative 1, and you're going to get your answer. Take that answer, and you're going to put that number you got into f. Take that number, put it into g. And that'll give you your answer. All right, good luck on that. Pause your video so you can work it. All right, write an explicit and recursive rule for the sequences given and simplify. Simplify it. So 5, 2, negative 1, negative 4, and on and on and on. All right, so remember your rules are a sub n equals the first term plus the common difference times n minus 1. I will give you that rule if you need it on your test. The first term, this is the first term, is 5. So a sub n equals 5. What is this doing? It went down 3. Down 3. Down 3. So it's going down by 3. So I'm going to say, do the common difference is going down by 3 times n minus 1. Now when it says it wants a recursive rule, I'm going to look real quick on your test and see if we have to do that. Yep, we do have one on there like that. So I'm going to show you this one because this is going to be recursive. So on your test, I'm going to say, I was looking on here to see what we've got. I'm going to give you a rule, and then I'm going to say find the 20th term, which you know how to do. You know how to do that one too. You know how to do that one. Okay. Yeah, I'm not real worried about that. I think y'all get it. Okay, on this one right here, if I wanted you to simplify it, and I know we did this a couple of times, this would be my explicit rule. In other words, I could say find the 20th term. And you would say, oh, well, I'll plug 20 here, and then I could find it. I could also ask you to simplify this. Let me come over here and do 5 minus 3 times n minus 1. 5, hippity-hoppity, distributive property. Let's do minus 3n. Negative 3 times 1 would be plus 3. 5 and 3 would give me 8 minus 3n. I could ask you to simplify it like that. That's fine, we could do that. On this one right here though, you're like, what is that one? That one's a little different. Well, this says f of 1 is 5. So that says if I want to find the 10th term, 1, 2, 3, 4, 5, 6, 7, 8, 9, I'll come this way, 10. There we go. The first term is 5. What this says right here, this says we're going to subtract 3 every time. You just kind of ignore this right here and look at what this says. Oh, we're subtracting 3. So I'm going to get my calculator. I'm going to do this. And by the way, this right here is the recursive rule. So I'm going to say 5 and I'm going to say minus 3. Oops. 5 minus 3. There we go. It's 2. And then I'm going to say minus 3 is negative 1. Now this is pretty cool. I like this feature. If I just hit enter again, because I told it to subtract 3, it'll keep subtracting 3. Enter, negative 7, enter. I'm going to let you finish it out. Go all the way out to your 10th term. So if I wanted to write the recursive rule for this one up above, I don't really ask you to write the recursive rule. I ask you to find the different terms. So I'm not really concerned about it. But if I did, I would say f of n equals f of n minus 1. That's just the way the recursive rule works. I'm subtracting 3 every time. So I would say minus 3. Which this one and this one, they're kind of all the same. Okay, so I wonder if I should do, no, it's already a long video. I don't want to get it any longer. Okay, slope and rate of change. We've already been working on this. It should be pretty straightforward. Let's find the rate of change, same thing as slope. So let's do this. Let's do 1250 minus 1625. So this is going down by 375, right? Down by, 1250, yeah, minus 375. That went down by more. This went down 875. This side went from 2.5 to 4. So this went up 1.5. 4 minus 7.5. So this went up 3.5. You're like, but wait, that's negative. It is, but I notice these are getting bigger. These are getting smaller. So my rate of change, the rate of change is delta y over delta x. So I'm going to do negative 375 over 1.5. So negative 375 over 1.5. So it went down 250 is my rate of change. I'm going to check, because it's a table, I want to check both. We'll do negative 875 divided by 3.5. If it's the rate of change, I should get 250 again, and I do. So my rate of change is nothing more than slope. Could you have done y2 minus y1 over x2 minus x1? Absolutely. You could have done that here. All right. Let me change pens to my red because it's a little easier to do with these. All right. Rise over run. So this goes through 0, 0. I'm just going to find another point. Looks like 1 right there. Rise up 1, run over 2. 1, 1, 2. So rise up 1, run over 2. My slope is 1/2. This one I notice it's falling, so this is going to be a negative slope. Let me put some points on here. You know what? This is just the opposite. Fall 2 and run over 1. So fall 2, run over 1. I could also say negative 2. Either way, negative 2 divided by 1 is negative 2. All right. Are we done yet? Oh my gosh, y'all, this is so long. Y'all going to be like all day doing this. Okay, we are finding the slope. So I need to see y equals mx plus b. So here we go. I'm going to get you started on these three. Oh, no, just this one. Move the x and divide by the y. Now, when you get your answer on this, I'm going to actually go ahead and do it because so many of you missed this on your test. I just want to go ahead and do it. Divide by 5. Okay, so y equals negative 8 over 5x minus 3. So many of you just circled this and said, there's my answer. No, the answer is the m. So the slope here is negative 8 over 5. That's my slope. For this slope, I'm going to label this x1, y1, x2, y2, and I'm going to do negative 3 minus 9. Where did that come from? Remember, y2 minus y1 over x2 minus x1. Negative 3 minus 9 over 7 minus, you always do the minus, negative 5. So negative 5. When you have two negatives together, you're going to bump them and make a gigantic positive. Now, you could do this on your calculator too, and that way it would reduce it for you, but I'm just going to work it. Negative 12, if you want to use your calculator right now, that is fine. Over 7 plus 5 will be a positive 12. If you did it correctly, you should get negative 1. Okay. On this one, x1, y1, x2, y2. So we're going to have 7 minus 1 over 9 minus 9. Ooh, that's interesting. That's going to be 6 over 0. Ooh, I'm going to check that. Here we go. I'm going to do 6 divided by 0. Oh, error, divide by 0. What does that mean? Not undetermined. So many of you told me undetermined. Undefined. It's undefined. You can't divide by 0. All right, what is the difference between, oh, looky here, undefined slope and a 0 slope? Undefined slope is Vux. It's undefined. It is a vertical line. 0 is hoi, I forgot my equals, which is a 0 slope and a horizontal line. That is the difference. All right, in Guatemala, they use, oh my goodness, who wrote this? Quetzals instead of dollars. I don't even know. I probably didn't say that right. What is the rate of change for this situation? So here we go. We got this. So you're going to do, I'll come over here. I'm going to label, you know what I'm going to do for this? I'm going to do this $1 and $11.25 and $3 and $13.75. I'm going to work it this way. X1, Y1, X2, Y2. I want you to work it, find the slope, the rate of change, and see what you get. I'm going to work it up over here. I'm going to do 13.75 minus 11.25 over 3 minus 1. All right, you're going to get that. All right, pause your video so you can finish that. Just hit your space bar. Arnold High School is purchasing uniforms for girls' basketball teams. The table shows the cost to purchase uniforms, including a flat rate fee of, oh, it didn't even tell me what the flat rate fee is. Write a function to represent the situation. Okay, so it doesn't tell me the flat rate fee, does it? So first off, let's figure out, write a function, and what is the rate of change. Let's figure out that rate of change, because we're going to need it. Okay, so I'm going to do, here's what I'm going to set up, 1, 20 and 3, 50. I'm going to set this up and figure out my rate of change. So I'm going to do 50 minus 20 over 3 minus 1. Okay, so I'm going to go here. Alpha y equals that. 50 minus 20. 3 minus 1. Making sure you're doing it. Not just waiting on me. Miss Dean, put it in your calculator. Hit enter. Oh my gosh, Miss Dean, why are you taking so long? Yeah. All right, it's 15. So that means she's charging $15 for the uniforms, right? All right, so here's what I want to do. I'm going to go right here, and I'm going to redo this X and Y. Now, if I need to know the flat rate, that means if you don't buy any shirts, how much do you pay? The problem with this table is it skips around. Oh, and I just skipped right there. Let's make that 5. So if I buy 1 shirt, it's 20. If I buy 3 shirts, it's 50. Well, I just figured out that it's $15, right? So what do I need to put right here? 20 plus 15 is 35. And then if I buy another shirt for $15, it's 50. If I buy another shirt for $15, it's 65. And that's what we've got there for, is 65. And then if I buy another shirt at $15, it would be 80. So, can you figure out how much they're charging right here? Well, I would just take 20 and subtract off 15, right, to go backwards. So we started at 5. All right, so that means the uniform for the girls' basketball team. The table shows the cost to purchase it. Let's write the equation. Well, looks like you take $5 plus $15 for every shirt. Now, if I want to write it as a function, I just need to say f of x equals. By putting that there, that denotes that it's a function. What is the rate of change? It's $15 per shirt. All right. So draw a graph that represents direct variation. All right, direct variation, so many of you asked me this. That just means it goes through what? It goes through the origin. It doesn't matter which direction, as long as it goes through the origin. Draw a graph that does not represent direct variation. Okay. It can be anywhere. I'm going to go here. There we go. It doesn't go through the origin, so it's not direct variation. All right, If y varies directly with x, oh, right there you're thinking direct variation. Y is 10 when x is 2. Find the value of y when x is 8. Think of it like this. X is 2, y is 10. Find the value of y when x is 8. This is what you've got basically. So I'm going to set up a proportion. 10 over 2 equals y over 8. And remember, the proportion is just y over x. I'm going to do the butterfly. 2 times y is 2y. 8 times 10 is 80. Divide by 2, divide by 2, y would be 40. So there's my missing answer. The height of a ball bounce varies directly with the height for which it's dropped. So a certain ball bounces 22 centimeters when it's dropped from a height of 50. How high will the ball bounce if it's dropped from a height of 90? Okay, so the height of the ball varies directly with this height. It doesn't really matter which way you set it up. The ball bounces is 22 and it's dropped 50. And then I want to know how high the ball will bounce if it's dropped from 90. The height was 50. So I'm trying to figure out this if I put 90 here. I'm trying to think which way is better to explain it. I don't know if you caught that. So 22 was it was bounce and then height is what I was doing. So I just want to set it up the same way, bounce to height. Once you get this, you can set up your equation. So 50 over 22 equals 90 over x. If you set it up the other way, it's perfectly fine, as long as you keep your proportions the same. That's what's really great about direct variation. So 22 times 90 is 1,980. 50 times x is 50x. 1980 divided by 50 is 39.6. All right, the height of a ball bounce varies directly with the height that's dropped. A certain ball bounces 22 centimeters when it's dropped from 50. How high will it bounce? Oh, I did it backwards, didn't I? Oh man. How high will it bounce if it's dropped from 90 centimeters? Oh no, that's right. They worded that wrong. Okay, I'm going to read that one more time, make sure I didn't mess that up and do it backwards. No, we did it right. So I feel pretty good about that. All right, so the circumference of a circle varies directly with the diameter. Write the direct variation equation. Now, when you see that, that's different. That's y equals k times x. If the circumference y is 220 feet, when the diameter x is 70 feet. All right, change my pen. So my x is 70 and my y is 220. I write it in ordered pairs to kind of help me keep it straight. So y over x, that's going to be 220 over 70. So I'm going to set this up, 220 divided by 70. I don't want it to be like that. I'm going to do math, enter, and put it back as a fraction. So it's 22 over 7. Okay, all I did was set up my proportion y over x. So this is 22 over 7. This is my constant of variation. When you set up that proportion, you're setting up y equals k times x. So it's going to be 22 over 7, and then you put x. And that gives you your equation. Use your equation to find the circumference of a circle with a diameter of 32 feet. Okay, so let's look. The diameter is the x, right? The diameter is x. So what they're saying is if I take y equals 22 over 7 and I change the x to 32, what do I get for the circumference, which was the y? So I'm going to say alpha y equals 22 over 7 times, what was I multiplying by? 32. 704 over 7. I'm going to do math, and I'm going to change that to a decimal. Let's see what that comes out to be. 100.57. I think I'm going to put that. That makes more sense in this situation. 100.57, and it is feet. There we go. Alright guys, I know that was a beast of a midterm review, but by doing it you will increase your chances of passing on the midterm exam. Thank you for watching.